In this video a small talk about resistors in electronics, and this is the title of the video, talking about resistors in electronics. And here you see some more or less common resistors. When you look at modern computer boards, you will often see more or less always tiny resistors with say 1 millimeter or so, but these are say the old school resistors that were used and still nowadays in 2025 used in electronics. This is a typical power resistor. It shows say 15 ohms and it can handle 20 watts. I will talk about that later. Here mini resistors, I bridged them in the past for a certain purpose. One is, as far as I could see, 200 ohms and the other one is 3.3 kilo ohms. Anyway, here a 10 ohm resistor, etc. Well, this is at first the schematic, and this is of course not a schematic to make something. It only shows say the things that I want to tell about the use of resistors. Here is say the most basic circuit that you can get. 18 volts here, a resistor of 10 ohms here, a load resistor of 10 ohms here. Say this is the resistor that precedes the load. That load can be everything. Say a kind of electronic circuit or another electronic circuit, and this is say 18 volts, and here we have two resistors of 10 ohms, and say in my ID in this video the load is also named with 10 ohms. Is that real? Well, it depends. This is only a demo about how to say study all these things, and especially in hobby circuits. Anyway, of course also in professional circuits these laws are also valid. They are say the constant working laws. That's Ohm's law. Say how the watts are calculated. Watt is volt multiplied by ampere. So here we have these laws that are valid in this circuit. In fact, in any electronic circuit or electric circuit, the wattage is often say told when they are talking about the heat dissipation in the resistors. Well, that's of course a serious thing. We have here current flowing from the positive to the negative or the negative to the positive. A current is flowing and the load, the resistor here and that resistor here, dissipate a certain amount of heat. So the laws are again, like I told, U is I maal R, voltage is amp maal resistance, wattage is voltage multiplied by the current, and that means that in such a transistor we can have a heat dissipation. When you are working with electronics, it's always a very good idea to say make circuits, and when you want to supply them with a current or a resistor, go for the lowest heat inside a resistor if possible. So what's about this circuit? Current flowing. Well, 18 volts here. Say we have here an endless current source. Say 3 ampere, 10 ampere or so. The current flowing is of course depending on the two resistors that are here in series. So that's Rx plus Ri is 10 per 10 is 20 ohms. The wattage is dissipated by the two resistors is a volt multiplied by ampere. So in general we have here 80 volts. The current is 0.9 ampere. The resistor is 20 ohms. So a 900 milliampere will flow in this circuit, and because the two resistors are exactly the same, they will dissipate. So over each resistor we have a voltage drop of 9 volts, and each resistor dissipates 8.1 watt. It means that in this example, it's only an example, both resistors get hot. So when you mount here a 1 watt resistor or a 0.5 resistor here and here, they will burn out immediately. Of course, in a certain way. Anyway, well, what's more to tell? Here is the other part of this video where I wanted to talk again about resistors. Ohm's law is here again. U is E multiplied by R. Voltage is current multiplied by resistance. And well, here are some examples. You must calculate them yourself. Anyway, 12 volt at 1K gives a certain current. 1000 ohms here, 12 volts here. 24 volts here, 30 volts, 40 volts, 12. Well, this is another idea. 12 volts at 100,000 ohms and 18 volts at 100,000 ohms. And when you have, say, studied this video, you can surely give an idea, say, calculate the maximum current that flows inside that circuit, 18 volts at 100,000 ohms, etc., etc. I did not do the calculations, but of course I can do them. And anyway, what's the meaning of this all? Well, there is a lot of meaning. Talking about, say, the maximum current that can flow, etc., etc. Say, when you make an experimental transistor circuit, you must know, of course, how high is the current that flows, in this case with an NPN transistor, from the positive to the negative, or a reverse, that doesn't matter much. How much current is flowing here. And you can in a certain way easily calculate it by using Ohm's law. You can also calculate it, say, the dissipation that you can expect in terms of watts. So the heat dissipation, when you use Ohm's law here and also the calculation in watts terms. I have to say, of course, that is, say, a certain ID given when the transistor is switched into saturation. So in this case, the maximum current that can flow sorry, from the positive to the base. And when that current is too high, the transistor will be damaged in a severe way. Anyway, so limit the current here to the base in this case, and then you can in a certain way calculate the maximum current that can flow. Such a maximum current is always, more or less always, in the datasheet. So you can use Ohm's law in that case. Relay, for instance, say such a 12-volt relay has in general a DC resistance in the order of 200 ohms up to 250 ohms. It means that you can, for instance, when you connect such a relay in series with the collector of an NPN resistor, when it has to drive that relay, you can calculate the current that flows here, the voltage drop, etc., etc. So that's more or less the importance of all these, in a certain way, simple calculations that you can use when you are working in electronics using, say, all kinds of resistors here, power resistor here, power resistor here, a medium power resistor. But anyway, the most important thing is that when you make an electronic circuit, the resistors that have to do the job must not get too hot. When they get too hot, they will surely burn out within a short time. Anyway, thanks for watching. Hope it was a little bit interesting. Pan over somewhat. This is the basic circuit. Two resistors here, they form a voltage divider. The voltage that drops parallel to each resistor depends on the resistor value. I want to refer to, say, all the circuits that are on the World Wide Web regarding this issue. I have by purpose used here two resistors of the same value for this demo, etc., etc. And what is volt multiplied by ampere? Again, thanks for watching.